Students and friends, welcome to my YouTube channels. My YouTube channel is Dr. Ashok G Make Solution. So what I'm going to discuss here, how to solve the very simple way conductions problem, either plane wall, either cylindrical body or spherical body. So previous video already we discussed plane wall trick and problems based on this already we uploaded in the video. This, if you will explain here how to remember, how to correlate plane wall, cylindrical body and spherical body. So plane walls already we discussed. There what you have to do, for single wall you have to see the heat flow rate T1 minus T2 by L by Ka. So that is thermal resistance. Now for cylindrical wall, what is T1 minus T2, 1 by 2 pi K L in ln R2 by R1. And what is convective heat transfer coefficient here? Area, you put 2 pi RL because area of the cylinder is 2 pi RL. So what is the convective heat transfer coefficient? The convective thermal resistance 1 by H into R. So these two you have to remember. So how this coming, you just see one derivations. Suppose Fourier's law of heat conduction, what you know? Minus Ka dt by dx for plane wall. If you know this for plane wall. If you are taking cylinders, what will come here? dr. Will come dr. And area is equal to what will come? 2 pi RL. Just 1 minute. Area will come 2 pi RL. Now we will substitute here 2 pi RL. See here. Q is equal to minus K 2 pi RL. Then dt. Now we will separate the variables. What will come? Q by R dr. Here dr is there now. Q by R dr is equal to minus K 2 pi L dt. If we will integrate this R1 to R2 and T1 to T2, so what will come? So here Q by R, so R will come outside because separate variables now, R is variable. So now if you ln R, so upper limit R2 minus R1, Q into, here what will come? Minus Ka not there, K, or you write in order, 2 pi KL dt. So T2 minus T1. If we will interchange this plus will get, minus will get plus. So 2 pi KL T1 minus T2. And if you will divide this, so it will come Q. What is? Ln R2 by R1. Ln R2 by R1. If you write this, see here, finally, 2 pi L will write here, T1 minus T2, divided by what is thermal resistance? 1 by K1. What is here? Ln R2 by R1. 1 by K1, R2 by R1. So see here, R2 by R1 K1. Here also if 2 pi L will take top, what will be the thermal resistance? 1 by K1 into ln R2 by R1. This is the single cylinder thermal resistance. Now what trick you have to remember? Now suppose 2 block will be there. Then here T1 minus T2, T1 minus T2, T2 minus T, T1 minus T2 to correct. Overall temperature, what is T1 minus T3? Suppose 2 cylindrical wall is there, T1 minus T3. Then thermal resistance for 1 block, again thermal resistance for 2 block. If 3 is there, again one more time, so add ln R4 by R3 plus K3 for conductions only. So temperature will come T1 minus T4, 2 pi L will be there. So this is the general terms. If you remember the one terms, this one, this is Q is equal to, if you are able to remember, or suppose UG strength, this is there in the data book, but competitive exam, this will not be there. So you have to remember a small derivation. Area you substitute, integrate, will come the formula for the conductions heat transfer for the cylindrical body. So trick is there, this is for 1 block, 2 block, 3 block, na just add, 4 block just you add it. But conduction and convection both will be there. Then what we have to do? So you know, see conductions convection heat transfer, what is area only we have to change, what is 2 pi RL. So I wrote 2 pi RL. What is convective thermal resistance? 1 by H into R. So that only we wrote first inside HA RI R1. Suppose RA you can write here, or R1, R2, R3. Suppose inner HI na HO, whatever symbols you will follow. So that means convection's thermal resistance, you add both side. How many how many cylindrical body will be? 3 now. One more times you add R4 by R3 plus K3. Here will come R4. So that is the general concept for the remembering the formula for the conduction heat transfer concept for the cylindrical body. Similarly, sphere also will be there na. You remember for thermal resistance for one, then thermal resistance for convective plane, and we can remember this full conduction problem and for conduction unit, and we can solve the any type of conduction problem, either plane wall, either cylindrical wall or spherical wall. So I am giving separate video. Plane wall video I given separately. This is the cylindrical body. Now one more video I will give trick to remember the formula for the spherical body. Okay, so watch the video, share this video to your friends so they can get the maximum benefit, and those still not subscribe the channels, subscribe the channels. Okay, thank you.